Welcome back. We're talking about the standard conditions. If you look at the cell, therefore if I take this and bring it here again to say, you can see in the cell, this one I've got solid electrodes. This one now on the other side we have got gaseous electrode, whereby now we insert a gas. So which means that now the conditions, especially in this, will be 3, whereas in this one the standard conditions will be only 2. So in the case which caters all, which is this one, will be, because the first one that is applicable to all is the temperature. The temperature it has to be of the surrounding, has to be 25 degrees Celsius. And then the second one is the concentration of the electrolytes. Concentration of electrolytes has to be 1 mole per dm cube. And then the last one, in that case of a gas, the gas pressure that is acceptable will be 1 atmosphere or 101.3 kilopascals. That is the standard conditions when the cell is in operation. Let's take one example of a cell so that now the whole thing makes sense to us. Let's take a well-known one, which is your zinc copper cell. The zinc copper cell. In the zinc copper cell, we have got the half cells, which one will have copper, and then the other one will have zinc. And then we have our salt bridge, and then the electrolytes. We can use copper sulfate or soluble salt like copper nitrate. Zinc sulfate is also okay. In this one, remember the concentrations of this electrolyte must be 1 mole per dm cube. 1 mole per dm cube. That is for our cell to operate under standard conditions. Now, if you go to the electrode table, it's very easy now to tell. Here we go to the table and find that now, according to the table, zinc has got negative 0.76 volts, whereas copper has got positive 0.34. Be careful on the copper. The only copper that is used is this one of positive 0.34. The other 2 half reactions are not used, so we are using only this one. Now, here now they are fighting for electrons. Which one is going to win the battle? The big one. The one with the greater electrode potential will always win electrons, meaning that it will be reduced. The one with smaller electrode potential will undergo oxidation, meaning that in this case, simple zinc, that's where oxidation will take place. And then that's where you will find the anode. If I analyze this, if I have to write half reactions, then this one will involve the reverse reaction. If I have to go to the increase and decrease in mass, this one has to go decrease in mass. That's a small analysis of this. This side, because it's big, then it will be, that's where reduction will take place. Reduction. That's where I will find my cathode in this half cell. That's where, if I write the reduction half reaction, we'll have to write the forward reaction. And that's where now there will be an increase in mass of the electrode. Increase in mass. Thank you. Now, in terms of polarity, we say the cathode will be positive and then the anode will be negative. In terms of the direction of electrons, they are moving from anode to the cathode, meaning that in this case, electrons will move from zinc to copper. Fine. So if they can now tell let's say write down the reduction half reaction, half reactions, then the reduction half reaction will be, it will involve copper. Therefore you go to the table and copy the forward reaction, which is copper ion plus 2 electrons forms copper. And then the oxidation half reaction, will be the one that involves zinc. Therefore you go to the zinc and write the reverse reaction. Zinc will form zinc ion plus 2 electrons. Now they can say also write down the overall or net reaction. Then in this case now you balance the two using the electrons. You can copy them, fine. Copper ion plus 2 electrons forms copper, and zinc ion, zinc forms zinc ion plus 2 electrons. And then when you balance the electrons, this cancels this. What is remaining on the left is copper ion plus zinc. That's on the left hand side of the arrow. Put the arrow on the right, there will be copper and zinc ion. This gives you 3 marks in an exam to say now left hand side is correct, right hand side is correct, 1 mark for balancing. So let's pause, we'll calculate the EMF soon. Prepare yourself for calculating the EMF. Thank you.